In this video, we're going to continue our talk about the statistical parameters and say that the next parameter is the mode, which is simply the most frequent number or the number that is repeated the most. So if you have data that look like this, let's say 2, 3, 3, 3, 3, 2, 2 4s and 1 5. So what is the mode in these set of data? Well, the most repeated number is the 3. It's repeated 4 times, but we say that the mode is the most repeated number, not how many times it was repeated. So definitely the mode is going to be the 3. The next parameter is the range. And the range is simply the maximum number minus the minimum number. So it's going to be maximum minus minimum. So the maximum number you have is the 5. The minimum number you have is the 2. So the range is the maximum minus minimum, which is going to be 3. The next parameter we have, which is actually the most complicated, is the standard deviation. So the standard deviation, it's the definition for it, it's the square root of the average distance it's the square root of the average distance squared of the numbers from the mean. Of the numbers from their mean. So it's very important to know that the standard deviation is a measure of distance. And let's see how we can get the standard deviation. So the way we can do it is, if you have, let's say 3 numbers like this, 9, 10, and 11, and another 3 numbers, 9.9, 10, and 10.1. Right? So the standard deviation, let's work it backwards. So it's the distance between the number and their mean. So first you start by getting the mean. What is the mean? It's the average, sum over count. So you add 9 plus 10 plus 11 over 3. So it's 10. Right? Now you want to find the distance squared between each number and the mean. So you're going to say that how far is the 9 from the 10? And how far the 10 is from the 10? How far each number is from the average of all the numbers? And how far is the 11 from the 10? Since I don't want negative and positive distances, I square them. And finally, I want to find the average, and we know that the average is the sum divided by the count. So you have 3 distances, 3 numbers. So you add these distances and you divide them by 3, and finally you take the square root. So this would represent the standard deviation. Let's try another one, and we'll talk more about the interpretation of the standard deviation. So first, again, it's the distance squared between each number and the average. So you need to get the average first to calculate the standard deviation. So the average of these 3 numbers is going to be 10 as well. And now you see each number, how far is it from the 10? So the 10, how far is it from the 10? And the 10.1, how far is it from the 10? And then you square the distances, because you want to get rid of any negatives that you might get. And then you want the average distance, so you add the distances up and divide them by their count. So again, you have 3 numbers here, and then finally you take the square root This is the final step to find the standard deviation. So you can see that the standard deviation is a measure of distance, or it's a measure of variation, how far the numbers are from each other. This is the interpretation of the standard deviation. As the numbers are closer together, the lower the standard deviation, because you see that this is definitely going to have a higher standard deviation than this one, because here you have smaller differences between the numbers. So let's say if I give you an example that you have, let's say, two classes at a certain school. So let's say class 1 and class 2. Let's say that the first class scores like this, 80, 82, 79, 78, 81, and 80. While the second class scores like this, 97, 62, 96, 95, 67, and 65. You might find if you calculate the average for both classes, you'll find them very close to each other. But does these two data look exactly the same? Obviously not. Which one is going to have a higher standard deviation? Well, we know that the standard deviation measures the distance between the number and their average. So as the numbers are further apart, the standard deviation is going to be higher. Because if I got, let's say, the average for these numbers to be 80 by adding them and dividing them by 6, if it's approximately 80, then you'll see how far these are from the 80. And compared to if you said that the average of these numbers is also 80, look how close these are to the 80. So the standard deviation here will definitely be much, much lower than the standard deviation in the second one. And this would indicate more variations. So a higher standard deviation, if I told you that the second class has a higher standard deviation, this means that there's much more variation in the scores of the students in this class. Some scored very high, some scored very low. The distance between the grades are a lot. So again, if you have numbers that look like this, 3, 4, 5, and 6, and numbers that look like this, 3, 3, 4, 4. Which one will have a higher standard deviation? The closer the number are to the center, right? So I have the 2 and the 4 are very close to the average, which is the 3. This means a lower standard deviation. Even the 1, 2, 3, 4, 5 are not necessarily far apart, but compared to this one, they are. This is going to be a higher standard deviation. As long as the numbers are clustered at the middle, this means a lower standard deviation, lower distance between the numbers and their average. As the numbers go further apart, this translates into a higher standard deviation or more variation in the data.